Hi, this is Krista Garakis. So we're going to talk about scientific method and laboratory equipment. But before we get started, I want you to watch the Monty Python video that's located on my website under the first Unit 1 video. So hypothesis is an educated guess. Basically, it's going to we use observations to predict an outcome. For instance, like we can see around this classroom that our lab benches are black, they're shiny, they're smooth. Those are some observations. Format is if I change my independent variable, then the dependent variable will change. So an example of this is like, for instance, in biology, we had a bunch of plants maybe. Let's say we change the fertilizer. So I changed the fertilizer. What could change because I changed the fertilizer? Maybe plant growth, or maybe they're shinier. That's a dependent variable. Another example of an independent variable could be, let's say I have water and I put different amounts of sugar in it. So if I increase the sugar, then my density will change. So I change the sugar, independent variable, and then the density changed because of what I did. So that's a dependent variable. So repeated trials, we always want to do more than one trial. So ideally, we would want to do it 3 times. This reduces random errors. Unfortunately, we usually do not have time to do 3 trials, so we usually end up only doing it once. But in an ideal situation, we would do it 3 times. Observations are something we note about what we're doing. So let's say I have a chemical reaction, it turned red, it was smelly, there was a lot of gas, then that would be some observations. Maybe around the classroom, we can talk about the desks, they're brown, they have shiny metal, things like that. Data, we always record our observations during an experiment. So whatever I'm seeing, smelling, touching, if it's safe to touch, then we would record it. So there are 2 types of observations. There's qualitative versus quantitative. So qualitative are things we see, or like, for instance, whether or not iron is present in the water supply. Quantitative is always a number. So how many, how much. So for instance, how much iron is in the water supply. So let's go back to our variables. We have our 2 kinds, independent, what I changed, and dependent is what changed because of what I did. So your independent variable is what I changed. If we were going to graph it, it would be on the x-axis, so that's straight across. And dependent variable is what changed because of what I did, so it's up and down. So let's say if I change percent sugar in water, then the density would change. So the percent of sugar would go on the x-axis across, and then the y-axis would have the dependent variable. So constants are things that remain unchanged throughout an experiment. So maybe pressure, air temperature, things like that. Control is the thing we compare things to. So let's say I'm talking about sugar water. So an example of a control would be the water. So just water with no sugar. Maybe if we were talking about the plants again, we were changing the fertilizer, maybe the control would be the plant without the fertilizer. Hi, this is Mr. Garakis, Miss G. So we're going to talk about significant figures today. So when we do measurements, there's always a certain degree of uncertainty. So some numbers can be absolutely determined and the others have to be estimated. So if we were measuring a length, the numbers we would know for certain are the 3 and the 4 there in the 3.45. The estimated digit is always the last digit, and this is different from what you've done before. So significant figures are all the numbers recorded in a measurement. So So we're going to use the Pacific Atlantic rule for determining significant figures. So what we're going to say is if a decimal is present, start counting from the Pacific left side from the first non-zero digit. So what that means is that if we were looking at 0.003400, we would start counting going that way. So that would mean that there are 4 significant figures. So if we're talking about 0.0056, we would start from the 5 and go right. That would mean I have 2 significant figures. If we were talking about 0.02, so that 0 there is not significant. So that would mean we have 1 significant figure. The exception is if a decimal is present and the number is greater than 1, everything counts. So that means that because there's a decimal there, everything's going to count. So it would be 5 significant figures. So again, there's a decimal present, it's greater than 1. So again, we have 5 significant figures. So again, the Pacific Atlantic rule, if no decimal is present, we start counting from the Atlantic right side of the first non-zero digit, meaning that we're going to start here and go left. So that means I have 2 significant figures there. Here, if I start here and go left, I have 2 significant figures. So there's no decimal. I'm going to go left. So I have 4 significant figures. So let's mix it up. All right. So for number 1 here, we have 0.00600. We're going to start counting from the Pacific left side, which means here, and going right. So that means I have 3 significant figures. For number 2, we have no decimal. So we start at the Atlantic right side and go left. Then we have 1 significant figure. So the rule is for number 3, if I have a decimal present, everything counts. So it's 4 significant figures. For number 4, if I start here, Atlantic right side, and then go right, then I have 1 significant figure. Again, on number 5, if everything, if I have a decimal, and then that means everything counts, so I have 5 significant figures. For the last one here, we're going to go here and then go left, then I have 3 significant figures. Okay, so we're going to talk about what worksheets to do, so I will give you that information on the board or on my calendar.
Inconceivable! Yes! Get there!
It's in the hole! It's in the hole!
Hey, have we learned our lesson? Inconceivable! Alrighty then. Yes! Yes!